Hello, in this video we are going to see SSL in action. First, let's get our browser ready. When you open up the browser, it's better for you to open with a blank page like this, and also you can go to options of your browser and make sure you're at the advanced category and using the network tab so you can clear your web content as well as user data if there is any, and click OK to accept it. Now let's launch Wireshark, and we're going to start a data capture and go back to your browser. The website we're visiting is Amazon.com. If you take a look at the URL address box, you will see that this address, www.amazon.com, starts with a gray globe. This is to say this is a regular web page. The secure socket layers has not been established yet. If you try to sign in on this page requests the login information and the password, which is very sensitive to the regular user. So by this time, if you look up at the address box, it's changed to a lock, and the start of the address turned to HTTPS. That's little s there, indicate the secure socket layer has been established on this page. Let's stop the Wireshark capture and see what happened there. Go back to the very top of the data packet list, and you can filter this list with SSL. Now let's take a look. The first two data packets are almost identical. The source computer is 192.168.1 and 3. That's my local computer, and we are visiting the web server 54.230.163 and 5. That's the server of Amazon.com. So it sent the client hello message first. The second one is from the same source to the same destination and the same client hello. So maybe the first client hello has not been received or replied. And let's follow the second client hello here. If you right click to it and follow SSL stream, it shows nothing here, but you can go ahead, close this window, and it will automatically filter the result using the stream, the TCP stream of that packet. You can also add another part of the filter, SSL, and that will limit the result of the data packet even more. Let's start on the first one, client hello. My local computer sent this client hello data packet to the server, and let's take a look at the details, see what my local computer said to the server. If you open up the secure socket layers and maybe expand more, this is a client hello message, part of the handshake protocols, and we can see the version of it, TLS 1.0, and the length of this data packet is 213. If you expand the handshake protocol here, what's specifically included here is the random byte. This is the byte that we can use to create a master key later. And cipher suite, my local browser will accept 16 different cipher suites, and the server may take one of them to communicate with the local computer. The very last one is extension signature algorithm, and that's the signature hash algorithm. We accept 8 different algorithms for this purpose. Now let's take a look at the next data packet, server hello. The server replied to us and say hello too. And it's also included a lot of detail. This is a server hello, and the handshake type is 2. It's also provided as random bytes, which again used to create a master key in the following communication. The server picked one of the cipher suite from our list, and then the server sent the certification to us. That's the handshake type certification 11. And the certification is include 4098 bytes, so a lot of information has been transmitted here. And we have several certificates right here. If you open up one of them, you will see this is a signed certificate, the version number, the serial number, and the signature, algorithm ID number, and the issuer information. This issuer is very signed, this company, and it's provided country name, organization name, and the unit name and term of use information. The validity of this certification starts from April 8th, 2014 to April 9th of 2015. There is also public key information and algorithm identifier. The same kind of information are provided in the two other certificates as well. Also, our browser wants to confirm the status of the certification. So this is the next message. Certification status, which is handshake type 22, and another level, it showed successful. So this certification has been verified as successful. The next part is server key exchange. The server sends public key to us, and here is the public key, of course encoded. And the server hello done means the server said we can go ahead start our communication now. From the client side, from my local computer side, the local computer should also exchange the key, and we provide our own public key as well, and change cyberspace. The next one, provide a new session ticket. You can see the session ticket right here, and exchange cyberspace, and also encrypt handshake message. Now if we remove the filter here, follow this packet here, the next packet will be application data. So for example, if we enter our ID and password to log in, it will show as application data. And for this application data, if you open up secure socket layers, it will show as encrypted application data. It's probably be our ID and a password, but it's shown in encrypted format, and no other computer can steal this information and read our ID and password.